All right. Kill myself. That's going to be a neat part of the video. Is everybody okay? Oh my God. You just don't want to be balanced, do you? Okay. All right, so what happens here is, yeah, everything without an H cancels. The first term here is the one that had, the first term that survived, that initial stuff, has just one H in it, so it's going to lose that H. Every other term has at least an H in it left over. You guys see that? Yeah. If I would have done fourth power, the same exact thing would have happened, except what would have been here? 4, x cubed, right? And so forth. So I get 3x squared plus 3xh plus h squared once I kill all the h's, right? Cancel some h's. And of course that becomes, let h go to 0. So you get 3x squared. So if f of x is x cubed, f prime of x is 3x squared. It's kind of insane. And remember, f of x squared, f prime of x was 2x. So what does it look like is probably true? How do I take the derivative of something with a power? The power looks like it comes down and then goes down by 1. Very interesting. So let's prove that very quickly by using f of x equals x to the n. So this will look like limit as x goes to x. Look, where's that coming from? H goes to 0. X plus h to the n minus x to the n over h. So this would be x to the n plus, now to be honest, the number here is going to be related to what's called combinations. It's going to be that number that comes from the Pascal's triangle, depending on what n is. But it's going to, in this case, it's going to end up being n. In fact, you can kind of see it here. See how n was 3, and this number is 3? Then it was 2, it was 2. X to the n minus 1 h plus a bunch of shit with at least h squared. Right? All over h. And then at the end it's going to be minus x to the n. So these cancel. This loses its h. And then I got a bunch of stuff with at least h. So as I let h go to 0, all this shit goes away. And it does exactly what it looked like it was going to do. The power comes down, and it goes down by 1. Oh my God. That's too beautiful.
In that sense, is that an n? Makes x to the n plus, and then your parentheses, is that an n? Yeah, right there. Is that an n?
That right there is an n, yes.
Okay.
Thank you, sorry. It's not a poor little stumpy h. Oh, stumpy. Now, to be honest, I don't know if you've noticed this, but on that differentiation, the chapter 3 sheet, it's on the back of this one, the one about graphing the 2/8. I've got what we just did here. So this is the power rule. Now, if I couple this rule with some of these derivative rules here, look. The beautiful thing about derivatives is it's what's called a linear operator. One thing about linear operators is it looks like it can distribute. So is the square root linear? No. Because the square root of 4 plus 9 does not equal square root of 4 plus square root of 9. It doesn't look like it distributes. Is that decent? Is that cool? Can you imagine if let me see if I can show you this real quick. If I was curious about h of x equals f of x plus g of x. and I want to know what h prime of x was. Just stay with me for a second. I would apply the limit definition. So here's h of x, so it'll be f of x plus h plus g of x plus h minus f of x minus g of x. Is everybody with me so far? It'd be throw an x plus h into that minus this whole thing. Plop. But do you see how this is really easy to see that this is just all the f shit over h plus all the g stuff over h. And what's the limit of this? That's just f prime. And what's the limit of this? That's just g prime. So the derivative of this, it looks like it distributes to both of them. Now it's not really distribution, because distribution is multiplying something in, and that's not, we don't multiply by the derivative really, right? We take a derivative of something. I guess am I teasing what's happening? So now watch how powerful this is then. Now that we can combine those two, and of course minus would work the same way. If I had a constant multiplier, it would just come out in front. So all those rules right there about how derivatives work. Now watch this. So I'll remind you, here's the rule. So if I had g of x equals 3x to the 4th minus 2/5 x to the 10th, what would g prime of x be? So what happens here? What's the rule say? The 4 comes down, it multiplies, so it's 12 x to the 3rd. You can just do 2/5 times 10 x to the 9th. So I get g prime is 12x cubed minus 4 x to the 9th. Shwa. Now this rule works even if it doesn't look like there's an x. What if I had h of x equals 7?
0.
Yeah, why? Because two things. Either that's a constant function and the constant function has a slope of 0, or if you really want to use this rule, how many x's are there? Yeah, x to the 0. A 0 comes down, kills the whole thing. So the rule works no matter what n is. All right, that's a kick-ass rule. So simple. But let me show you something kind of nifty here. So what have I had? F of x equals x to the 4/7 minus x to the negative 2/5. All right, the rule doesn't give a shit. It doesn't say anything about what n has to be. There's no restrictions on n. So what happens here? 4/7 comes down. X to the... You want to see something kick-ass? If you're subtracting 1 from any fraction, you can do 4 minus 7 is negative 3 over 7. 4 minus 7. Negative 3 over 7. Negative 2 minus 5. Negative 7 over 5 is what it's going to be. Of course, that's how it works, because 1 is going to become whatever bottom you need, and that's how it's going to freaking work. But it's a beautiful shortcut for this, for derivatives of powers where they're fractional powers. Right? That kicks ass. So this will be 4 minus 7, negative 3/7. Now that, when it comes down, what happens? Yeah, plus 2/5 x to the negative 7/5. Kick in the acid. Every time we do it, every time we learn a new derivative of a different function, we have to remember that it does go back to the limiting process. We're going to start to develop derivative rules for functions that we don't have to go back and do all the limit process for every time, thank God. Right? So now polynomials, we know how to do the derivative. You only have to do it if Evil Jeff says use the definition of derivative, which you know he will, because as I just said, I'm evil. All right, cool. So you guys try the ones on this. They're at the bottom there. And we'll talk about this here in a minute. Try those 3 problems.